All right. Hello, hello. Hello out there. Good afternoon, good evening, good morning, wherever you're joining me from. This is Aaron from Solace, back at you with another Solace office hours. Ask me anything, ask Aaron anything. I'm here for an hour. It is noon here in Singapore on December the 9th. Hope you're enjoying winter if you're in the Northern Hemisphere, or summer down south. Singapore, it's always kind of the same, so it's just hot all the time here. Anyway, happy to be here and answer all of your questions. Any questions you got? If you're on the chat, I'll try to keep an eye on that. Come say hello. We are broadcasting live on YouTube, Twitter, and on LinkedIn. So yeah, say hello. Tell me where you're watching from. I'll try to keep an eye on the chats. Let me know if there's any problems with the broadcast, I guess. I'll try to remedy it as best I can. But yeah, we're gonna go take a look at the Solace community. My voice is a little shot because I had a 3-hour workshop yesterday with a customer, so and that went kind of late. So I woke up this morning feeling a little sore. Let me switch gears here. There we go. Okay. Solace community, your one-stop shop for all things Solace Q&A, new announcements, of course, where we talk about upcoming things like our new Python API. The customer I was talking with last night used Python quite a bit, and they're quite happy to hear that we are building a native Python API. If you don't know about that and you're a Python user, you should check it out. There's an announcement right here at the top. My colleague Tamimi is a Python guy. I really should learn Python. I don't, but yeah, and you can download an EA version of it and give it a try. Play around with it. Hello from Abu Dhabi. All right, hello, Sandeep. How are you? Hope you're good out there. Do you have a question? You have a question for Aaron? I got my whiteboard here. My CPU is a little maxed out, so I'm hoping that the audio connections and everything are going okay. One thing I kind of that was interesting to talk about yesterday during this workshop was the concept of eventual consistency in architecture, in distributed architecture, talking about distributed microservices and distributed applications, and how event-driven architectures like Solace can kind of easily allow for eventual consistency, where think of it like your database. If your database was the center of your world and everything had to be always kind of consistent, that would essentially be like a very transactional view of the world, right? Every update to the database, everybody else would be able to see that update, and everybody would have the exact same view of the entire state of the world. But it doesn't lend itself well to higher performance applications and architectures. So, so this concept of eventual consistency is like more like, as long as the downstream systems get updated eventually, maybe there's transactions or logs or whatever that, it's not tied to the kind of the critical path. As long as you get that data in there 10 seconds later or 30 seconds later, it allows, that's a better architecture. You might have to resolve inconsistencies later at some point. There are checks you need to do, but it allows you to build a much more throughput-oriented system, right? This one author, this architect guy named Gregor Hoppe. Oh, hi, hey Sandeep, yeah. How's it possible we're going to help with specific problems, event-based scenarios, and eventually consistent transactions? Well, Solace does have transactional support, session-based transactions, and if you use JMS, it does support XA transactions as well. So you can be very transactional using a Solace and event broker, but it allows you to kind of pick and choose what your best kind of pattern is. A lot of RESTful architectures, request-reply based, command and control. You want to get the results of something. You're blocking there, waiting for some result to come back. But if you need to just update systems eventually, yeah. So this author, this architect, Gregor Hoppe, wrote a book on distributed enterprise integration patterns, and he explained it like think of Starbucks. Starbucks is an eventually consistent architecture, right? You pay for your coffee, and that part is done. And then, you know, sometime later, 2 minutes later, 3 minutes later, you get your coffee, right? If you had a transactional view of the world where each person, as they paid for their coffee, had to wait until they got their coffee so that there was a consistent state, the throughput would be very, very slow. So by decoupling the payment and the delivery of the coffee, you have eventual consistency. Of course, you know, if they forget the order or something goes wrong, you know, you might have to rewind that transaction, or, you know, try and figure out, you know, make another coffee or refund the money. So, you know, there is some error handling that needs to happen, but you get a much higher throughput by having this kind of eventual consistency in your architecture. So yeah, you know, in the Solace world, we can think of that as, you know, you publish to a queue, you publish an event on a topic that might sit into a queue for some time, you know, if you're using a topic to queue mapping or bridging, and then, you know, that your downstream system will eventually consume that queue. You know, something like a welcome email, you know, that does not have to be tied to your provisioning system, right? When you sign up for a new account, you know, it's nice to get a welcome email, but, you know, that's not part of the critical path in terms of the order activation. So yeah, pick and choose, you know, what microservices are, you know, part of the hot path and not. Let me pull up my whiteboard here. No. So how did Sumit do this? Making a request, and you have to talk to a number of different services. You might have some that are, you know, that need to be, you know, this one is important, this one is important, but after these two are done, you know, that then the response can come back and say, yeah, we've updated your thing, we've updated your account is active, or whatever. These two guys, if you're using Solace, you know, could have a queue sitting in front of them, and the messages could be, you know, via topic routing, via topic mapping, can go into these queues, and these guys can eventually get these messages, right? So, you know, these should be maybe black. These are Solace queues here. And so that way, you know, this guy here is not, if you know, if this takes maybe 30 seconds or, you know, 10 minutes or something, you know, these guys are not blocking here waiting. This guy's not sitting here waiting for these guys to come back. So it allows for a higher responsive system, not having everything blocking and synchronous to the end. Let me just get rid of that. Okay, so I got the whiteboard is working. Okay, so let's check out some questions on the community. I'm gonna give it a refresh in case there's anything new. And we're just gonna go through here. And yeah, if you're out there, you're listening, you got a question, that'd be great. What was the title of the book again? Sounds like a great one to add to the list. Yes, it's Enterprise Integration Patterns. It's a website. He actually made a website for it. Enterprise, yeah, there we go, bookmark. EnterpriseIntegrationPatterns.com. Check this out. It was written, I think, 2005-ish. And he's got a couple talks on YouTube, and it's great. So if you're doing, you know, people that understand, that know JMS, this will be very, very familiar stuff. But as the rest of the world has kind of moved into, this applies very much to modern microsystem architectures as well. And he's got, I mean, if you click on any of these, there's a picture. There's a picture that kind of shows all the different. There's somewhere, yeah. So he's got diagrams of everything, messaging patterns. Let me back up. There we go. Yeah. So it kind of talks about all the different patterns and how you do. So Solace, I've looked through this. Solace applies to most of these, and I've actually been thinking about writing a blog or writing a page or something where I kind of show Solace's feature set kind of mapped to these integration patterns. But yeah, very, very applicable in the Solace world, in modern microservices, in any kind of distributed architecture. This is very good to check out. So yep, highly recommend it. And yeah, the author's name is Gregory Hoppe. You can find him, I guess, up here. There he is. Yeah, Hoppe. That was close. Okay. And yeah, really smart dude. Okay. Okay, so let's see here. Dun, dun. If you got a question, please ask it in the chat. I'm happy to chat about eventual consistency, microservice architectures, topic design, software versus hardware, all sorts of other things. Let's see, we got some questions here. Oh, Hong, my colleague Hong there. Let's check this out. Oh, this is one of the ones that I was asking about. This is an interesting question here. The original thing was this guy was trying to basically round robin between two different software brokers, two different message VPNs running in two different regions, and have messages kind of round robin between the two. And people that know Solace know that you use VPN bridges to do bridging between different brokers. You can use the event mesh DMR as well. So there's two different ways. There's DMR and there's VPN bridges. VPN bridges gives you that kind of static routing. But they wanted to round robin message delivery across two different bridges. And so kind of like a non-exclusive queue type behavior. And I came up with an idea. I thought my colleague Ken here, I wrote a bunch of stuff. And then I thought, hey, we have this new feature, well, it's about a year old, called shared subscriptions. If you don't know, if you're familiar with MQTT, you'll probably know shared subscriptions quite well. But it allows you to do kind of groups of consumers and do a non-exclusive or round-robin delivery for direct messaging. And you just need to use this pattern here where in Solace, it's pound share. In MQTT, it's dollar share, and then slash the group name, and then the topic. So if you want to subscribe to A/B, you want to do round robin, then you'll have hash share slash consumers slash A/B. And everybody that subscribes to that will be part of that consumers group, and then it will round robin. So I thought, hey, bridges could do that. Bridges can be just direct messaging. So if we're only using direct messaging, and so I kind of drew a picture here. So this is what they wanted to do. We have messages being produced, direct messages being produced in VPN 1, and round robin between VPN 2 and VPN 3. So the bridges actually would use a shared subscription. So this bridge would be subscribed to the shared subscription. This bridge would also be subscribed to it. And then when the messages are published here in VPN 1, it would actually round robin between the two bridges. So an interesting way of doing round robin load balance delivery using shared subscriptions on a bridge. So yeah, if you're wanting to know how to do that, you can check out this this page. I thought it was a neat use of shared subscriptions, not just for load balancing clients, but maybe load balancing delivery across different different environments. All right. What's this one? Yeah, integrating Solace with logging. Now, Solace has a syslog output, so if you actually want to monitor Solace itself, there's different ways of looking at the event logs. Every time an application connects or disconnects, there are logs. But some people want to use Solace as transport for other logging data, right? So using it similar to MQTT or using it similar to Kafka, being able to send log events as messages on Solace. So if you're interested in that, check out this thread. It's pretty good. My colleague Ari here did a blog very recently on solace.com/blog on using elk. It's right up near the top here. Here we go. Check that out if you want. And yeah, something that I didn't know. So if you're using elk, I used to use elk a while ago, quite a while ago, and it's written in Logstash. You know, if you're using Logstash to basically do your kind of integration into Elastic, it's written in Ruby. And so I wanted to develop some input and output plugins, but it is you know, it uses Ruby. I don't know Ruby. But there's a way to do it with Java now. Someone made, this is about a year and a half ago, made a Gradle project that uses Java, and you can basically compile it into a Ruby gem. So you can make your own Logstash plugin, Java. Yeah. I was very happy to do this. So I built a little Solace Java plugin. So you can use JMS if you want, but I want to write something that uses native JCSMP, which allows for dynamic topics and all sorts of other cool stuff that the default JMS one doesn't. I'm gonna write a blog. I guess I'll post the code somewhere. I'll probably put it on my GitHub. But if you're interested in integrating Logstash with Solace, there's lots of good references out there, including this blog by my colleague Ari and this thread here. Come ask questions and we'll sort you out. I think I talked about it here a little bit. Yeah. Aaron, we use syslog plus syslog FluentD. Cool. I haven't played with FluentD yet, so I'm gonna have to try that out. You have to give that a go. Aaron, what about Istio? Is it going to be enabled on Solace? Istio as a service mesh? No, because they kind of fundamentally do similar things but different things. So like Istio is really good for, it's a service mesh which allows RESTful applications and architectures to have more of a kind of an event mesh style of data distribution, right? So using the sidecars, they can intercept all these REST calls, and using the control plane, you can actually modify how your microservices connect and talk to each other without the microservices actually knowing. I'm just going to highlight that question. Wow. Yeah. And so, so what Solace is doing for event-driven applications, Istio does do for kind of RESTful, REST-based architectures. So where the actual microservice doesn't necessarily need to know who it's talking to or where that data is going, or if it's being being sent somewhere else in the mesh. That's up to the kind of the management of the control plane. And so with Solace, it's something similar, right? Using topics, using descriptive topics in the event mesh to route that data where it needs to go. It allows your applications to just send these events, send this data out into the mesh, and using topics and publish subscribe, the data will get to where it needs to go. One of my colleagues actually did a kind of a technology mashup of Istio and Solace as a way to kind of running. We had software brokers running inside Kubernetes, and there was some kind of translation between service calls into the service mesh and Solace. I don't know if it's I should try and find there's a blog about it. I don't know if it was ever made public, but there is ways to integrate it, but they're more supposed to be complementary. That's the main thing. So they wouldn't necessarily replace each other. They're really kind of meant to be more complementary, kind of RESTful versus event-driven microservices. So yeah, good question. Monitoring Solace itself. App Dynamics and Dynatrace. Yes, there are. We have some of our big enterprise customers in finance use Genios. I've seen people monitoring with Prometheus and Grafana for more time series stuff. We do have customers using App Dynamics. I don't know if they're public, if the plugins are public. So that's something I would have to look into. Do some Googling, I guess. But I mean, Solace has this very RESTful, monitoring HTTP-based management API, right? So if you Google Solace SEMP, this is how you monitor Solace remotely. So actually, there's two different ways. There's syslog and there's SEMP. Syslog is your for your eventing, so like when events logs are generated, such as a client connects, or there's a threshold breach, the connections are too high, or I don't know, the disk is full, stuff like that, queue is full. These are generating events, event logs, and these can be outputted to a syslog server. And there's blogs and all sorts of stuff here. I actually, on my GitHub, if you check this out, GitHub, Aaron, Solace logging config. So Aaron-613 is my GitHub. Shameless plug here for myself. I used to do more logging and stuff. Yeah, go away. Got it. I have a bunch of logging configuring log file stuff here for syslog-ng, rsyslog, and logstash, some rules. And I've actually done some updates to this. I'm gonna have to update them. But yeah, if you want to like a quick and easy way to plug Solace's logs into your architecture, check this out. But it's if you just do some Googling, you'll find all of the kind of the commands and controls in our docs and everything. So that's logging. So things like, yeah, threshold breaches and stuff like that. But then for getting metrics out, you will be using SEMP. So this is the more polling kind of like what's the state of the world. So rather than using syslog to kind of emit things asynchronously, this is, you know, every minute you poll and say, show me all the clients, show me all the queues, show me all the data. And this is all very well documented in here. So there's a monitoring API, there's a config API, and it's using SEMP to actually kind of do all of that. So I think, I mean, we definitely have customers using AppDynamics. I just don't know if they wrote them themselves. I would have to go and do some digging around for that. How does DR between data centers work with Solace? That is a good question. So we have a feature called Replication. Solace. Can you just do Solace DR? Ugh. DR? Yeah, there we go, right at the top. So our DR feature is called Replication. So let me pull up the whiteboard here. Let me pull up the whiteboard. I have some slides for this, but I don't know where they are. So here is data center 1. Here is data center 2. Inside you have your Solace broker. And, you know, if this is a production deployment, this will be a HA pair. You have your HA pair of brokers. It's really messy. And you have your apps sitting out here. So apps publishing and subscribing into Solace. And so the DR feature, so HA is configured, and this is for automatic failover, so that, you know, if you lose a single broker, you know, activity fails over to the mate. So there's always 100% availability for, you know, in terms of capacity for the backup, you know, using that active standby model, which is much more, you know, kind of deterministic than a clustering type of HA model. But replication is, you know, if you lost this entire data center, then things are bad. So there's a feature, called replication. And if we have our two, you know, you could have 1 or 2 brokers configured down in the data center 2. So it's data center 1, data center 2. You can configure on a topic by topic or queue by queue basis which data is getting sent down here. And you can actually configure it whether you want it asynchronous or synchronous in terms of the Acls. So this is only for guaranteed messaging, right? So this is for your high value data, the stuff that can't be lost. So when I publish a persistent message, right, so the message will come in here, and before the publisher gets the acknowledgement, you know, let me change colors here. It needs to get sent to the backup, and then at that point, you know, you get the acknowledgement. But if you have DR configured, then the order of it would be, it gets sent to the backup. If you want to send synchronous, then it actually gets published down here across the WAN, sent to its mate if there is one. You know, this is optional here. Then this guy acts, and then this guy acts the original call. So at that point, the publisher knows that this data is in 1, 2, 3, and possibly 4 different Solace brokers. Yeah, so it's built into the product. You don't need external tooling like Mirror Maker. It doesn't use SAN replication. What it does is it actually uses Solace's own messaging, right? So it's kind of like a private event mesh between these different brokers, and the data is sent down to its mate. And, you know, as you know, so if this is in a queue, you know, this is publishing on a queue. As these guys read this data, you know, he's reading this data out of this queue. The acknowledgements are also sent down to the DR side. So there's these standby queues sitting down here, and there's messages inside them as they come down. And as these are acknowledged, these acknowledgements, you know, so if acknowledgements are green check marks, the acknowledgements, you know, as they read them out of this queue here, they're actually getting sent. Also, the Acls are getting sent down here, and these messages are getting deleted out of these queues. So you can, yeah, without using any external software or any other type of other processes, I guess, I don't know, whatever the term is. But you can, yeah, you can set this up using the software brokers or the hardware. And yeah, that's how it works. When something goes wrong, like if there's the crash, the actual data center goes dark, for our HA, between these two, this is considered like an HA pair. The failover is all automatic, right? There's watchdogs and heartbeats and all sorts of other stuff where the standby broker will automatically take activity for the pair if it notices that the primary has died, if it's gone away. And the APIs, Solace APIs here, automatically go into a reconnect loop, and they'll connect to the standby. For data center failover, though, for DR or replication, it's a manual process. It is an admin has to log in to this box and just run a single command that says activate. It's not automatic because the DR failover operationally is kind of a big deal, right? It's more than just the Solace broker. If you've lost a data center, there's a lot of running around. I don't know if you've ever been in production support, but I did it once or twice, and yeah, we lost a data center once, and it was a bad day. Yeah, failing over to DR, you don't want to do it automatically because you don't want to make a mistake and fail over to DR accidentally. So that's a manual thing. One neat feature about the DR, the replication feature, is it's on a message VPN by message VPN basis. So this doesn't apply so much to the software broker because more people tend to typically deploy lots of small brokers and have one VPN per broker. That's quite a common pattern with the software. But if you're using Solace's hardware brokers or appliances, typically those will have dozens or maybe even hundreds of message VPNs on each physical box. And so in that case, you can actually have it set up where you could have some VPNs that are active normally here, and then they're on standby down here. And then you can have other VPNs, so like maybe, this is VPN 1, VPN 2. You get a VPN 2 that is actually active down here and, standby up in data center 1. So you can have, if this is Singapore and this one is Hong Kong, you can have apps that are natively kind of in one location or another, and the other side is the DR mate for that. So yeah. Replication is the name of the feature. Check it out. That is where you'll find more information there. Okay, my messy writing. I need to get a better stand for my whiteboard because it's it wiggles around a lot when I'm writing. So yeah, thanks for the question. All right. Hey, a blog. Oh, okay, here we go. Thanks for doing that work for me. Thanks, Ari. A blog on how Event Mesh works together with Service Mesh. Great. So if you are keen about Service Mesh and wanting to know how they complement and work together, just Google what some of these terms here, and you'll be able to see it. Thanks, Ari. How you doing? All right. Tariq, hello. Will Boker still be part of the Event Mesh once it failed over to DR site? So the combination of DR, the disaster recovery, the replication feature here, and the Event Mesh DMR kind of capability, this is actually, these features kind of came about separately, and there's been a lot of work to kind of get them integrated. The short answer is yes. You will have your DR, you'll be able to fail over to DR and have your DR applications and your DR architecture part of the Event Mesh. It'll get essentially recombined, I guess. Once that DR site activates, they'll get kind of added to the Event Mesh and allow data to flow down there, even though you've switched over to DR. So yes, that is possible. It gets a little complicated with lots of DR sites and DMR meshes. It's not something like super trivial. I think we're building some kind of automatic deployment kind of architectures for that. So check that out. But yes, it is possible. It's just not something that's super simple. I think it's something that I actually don't know all the details myself. So I'm not going to try to explain it. Maybe I should look it up. I'll look it up for the next time. So hey, if you come to my next office hours, I'll do a bit of homework and I will whiteboard how DMR plus DR works in Solace. I know it's possible because I've seen some presentations internally. I just don't know it myself. So yeah, thanks for the question. Yeah, all right. Oh, Ari already answered. Thanks, Ari. Hello from India. Hello, Sikandar. How are you? Thanks for joining. Hello from Singapore. All right, good stuff. Okay, so we've had a lot of architecture questions. We've talked about DR and logging. Are there any developer questions out there? Is there anything about coding? You know, I love talking about this stuff. I mean, I'll talk about anything Solace, really. It is an ask Aaron anything, right? So ask me anything. Bum, 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 bum. What else do we got here? Any other questions out there? If you got a question, put it in the chat. I am keeping an eye on it. Yeah, I'm trying to keep an eye on it. I got my colleague Ari here looking over my shoulder, keeping me working. All right. Let's see, what's this? It's just Hong posting about that. Yeah, the event portal. Do people know about our event portal? I mean, this is one of the awesomest, newest things that Solace has done. You know, people have known Solace technology for years, using messaging applications, building for eventing. But whenever you're designing a large distributed architecture and application, there's been no tooling to help you define like what are the topics and what is the topic structure and how do I maintain this. Like you always end up using like Excel. I've used Excel for so many topic structures, Word documents for tracking all of the the different payload types, all that kind of stuff. If you don't know, you should know that yeah, Solace has an event portal that actually helps you design and catalog and even discover stuff about your event-driven architectures. The discovery is actually really cool. If you have a Solace architecture, you have a Kafka architecture even, you can turn this discovery agent loose in your environment, and it'll actually go out and kind of find different consumers, different publishers, what topics there are inside your architecture. You can import it and visualize it here in the discovery. Very, very cool. The designer is where you can actually build event-driven applications. I got a bunch of, these are all different domains, and this is one of the ones I was working on more recently, our New York taxi demo. I obviously haven't laid this out in a while. Let's start to fix this. I'm not going to go around and fix this. Anyway, this is all the events, different applications. I need to get a layout here. Every time a ride update event happens, these are all the different consumers and publishers of it. You can double click on it to actually go into it, take a look at the schema. Yeah, see what applications are subscribing to it and publishing to it. Here's the schema for it. Very, very useful. Yeah, check it out. I can have a point, latitude, it's a number, longitude. I even have a range. Beautiful. Look at that. Heading. This is all the payload. This is a JSON payload, I think this one. Is it? Yeah, it is. JSON payload. To help you kind of catalog your event-driven applications. Underneath, Solace is integrated with Async API. If you haven't heard of Async API, it's an open source initiative, asyncapi.com. Let's do a plug for them. Everybody out there, I'm sure, knows Swagger, right? Open API for designing RESTful applications. If you ever used Solace's SEMP library, it uses Swagger. So Async API is an open source initiative, and they basically are building an equivalent for event-driven applications. Hey, good news. Check that out. I didn't know that. Async API is partnered with Postman. Postman, very RESTful oriented. Looks like they're heading towards the event-driven world. Asynchronous APIs. Very fantastic. If you know JSON, if you know YAML, this will all look very familiar to you. It allows you to specify your publishers, your subscribers, your topics. Check this out. Hey, there's Solace. All right. Anyway, check out Async API. But under the covers, the portal actually uses Async API. You can actually generate source code from these things. So if I have an app, here's my mobile application. Let's double click on that. Click on Async API code gen. I can actually go ahead and, yeah, why not download that. Writer mobile application. Let's go check that out. Let me zoom in here. Downloads. Then writer. Ta-da! So I can go ahead and design this application in my portal and then spit out a bunch of config, async API configuration, and I can feed this into actually code generators. So on async API, there's actually code generators for, I think, Python, for Java. We have a Spring Cloud Stream one. You can actually take this and generate a skeleton that is based on all of this. So pretty cool stuff. If you don't know about it, you should know about it. I think it's free to sign up for the portal and at least give it a try. I highly suggest, if you're keen on exploring the new stuff that Solace has as part of our platform, you should definitely check that out. So yeah, solace.cloud will point you to where you have to go to sign up for that. All right, here's a question. Oh, that's a big question. Thanks, Tariq. When do we use Solace over Kafka and vice versa? Yeah, we get this question all the time. So I mean, I'm not. Yeah, let's get into it a little bit. So I would, they're both technologies that can move data between applications. They've come at it from very different views, right? Kafka was built at LinkedIn to ship log data around, to ship it into their analytics. So basically reaching out to a lot of points and streaming, funneling it into their streaming analytics for doing big data. So you can think of, and they use a lot of the same terminology, right? So Solace and Kafka both talk about topics. They both talk about pub sub, but they've implemented it in very, very, very different ways because these are just kind of patterns, right? So concepts. Like a topic in Kafka is a log file or a log files. It's, each partition is a log file. And so, when you think of a topic in Kafka, it's very much like you're writing to a file on a disk, and it's this kind of log of information. And then when you're reading from that topic or that partition, you're just reading from that log file. So it's very much like a broker-centric concept. Whereas with Solace, we have this. I mean, if you take a look at the, let me click on this event here that I just happen to have right in front of me. Will that load it? There we go. Look at this topic. This is a Solace topic, right? Taxi NYC/ops/ride updated v1 and then a bunch of variable information. So every time I publish an event, this is quite a pretty long one, right? I have a domain, taxi NYC, ops is this is the application, then a domain. You can basically make this as complicated or as simple as you want, but it allows you to specify with a lot of granularity exactly what type of message this is. And then using wildcards on the subscriber side, I can subscribe to very specific information. I can put, I can fill out all of these variables completely. Say I want to receive this driver ID or this passenger ID, or you can put wildcards and use, put stars here and receive everything. So Solace has a much more kind of fine-grained approach to filtering within the broker, whereas in Kafka you need to use something like K-streams to kind of do the filtering in the client space, right? You kind of have to read in a whole topic and filter it and kind of write it out to a new topic. They both have their places. They're both different. If you're doing a lot of, Kafka is not really good at like a many-to-many type of communication style, whereas Solace is more event mesh, allows for that kind of very dynamic way of having data kind of flowing everywhere at once. Kafka is very good for funneling data into analytics. I wouldn't want to try and replace. I mean, that's what Kafka does really well. So I would say that's where it fits very well. Kafka doesn't have the concept of non-persistent messaging. Everything's on a disk. It doesn't really do request reply. It's kind of one directional only, right? It's kind of like you're taking data from here, maybe you're doing some transform and you're pushing data out over on that side or into some analytics. Whereas, Solace is kind of more of a anything to anything. There's just Google Solace and Kafka, stick that into Google, and there's a page right here on our homepage that talks about it in more detail than I'm getting into right now because I can't remember all of the bits and pieces. But obviously this is going to be a bit more of a Solace take on it. But check that out. It might give you some ideas. as to where they both fit. Solace does have connectors for Kafka. You can find this on our GitHub page. So if you want to integrate Solace and Kafka together, they do play well together. I have actually a code lab. If you don't know, Solace has code labs. So codelabs.solace.dev, or just go to solace.dev and you'll find them there. This is our developer portal. So rather than go to solace.com, I often tell my developers to use solace.dev. And in here, if you want to integrate with Boomi, if you want to integrate with Kafka, there's all sorts of getting started. And this one is one that, did I write this one? I think this is mine, yeah. Talks about basically how to basically go through setting up a Kafka connector. So whether you want to do input or output, a source or a sink, it's all there. And yeah, the connectors are on our GitHub homepage. So if you want to do integration, you can use that too. So choose which one you want for the use case. Don't try to shoehorn one into the other when it doesn't really fit. But yeah, check out our webpage for a little bit more specifics, I guess, on kind of some of the differentiating factors there. So thanks for the question. Sorry if that was kind of rambling. I ramble a lot. All right. Solace running on machine image has any integration to Slack alert notifications? I don't think, not out of the box, but it's definitely possible to hook up a little bit of wiring to have our syslog events get put into Slack for notification. I'm sure that's possible. I wonder if Ari wrote that back. No. Yeah, I don't know. There has to be easy ways of doing that. Using Logstash maybe, or using FluentD. There must be some way of doing Solace event notifications there, or alerting from our event log. Interesting. I don't know, but yeah, not built into the machine image. So yeah, you would have to have something external that would push it in there. What else we have here? What about messaging pushing events all the way to client devices, such as any design consideration to make that highly scalable? That's a good question, anonymous LinkedIn user. So yeah, one thing that Solace does very well is large-scale connection scaling. Our software broker, the largest scaling factor. So the software broker, if you throw more RAM at it and more CPU cores at it, you can scale up the number of connections up to 200,000. Same with our hardware device. The maximum is 200,000, which is a lot, but not millions. So there are different ways of doing tiered architectures where you have lots of software brokers kind of as a connectivity tier, fronting all of the, I should pull up my whiteboard again. That would actually be useful. Dun, dun, dun. Whiteboard. Wow. Go back here, 1 second. I'm going to erase all this. Boom, gone. Whoop. Do I need that? No, I'll just erase this too. Delete. Doesn't want to delete. All right, whatever. I'll leave it there. Okay, so yeah, you will have lots of software brokers running in the kind of, I wouldn't say the edge, but this is where your millions and millions of devices are connecting. Because Solace does, MQTT, you don't need to use like Kafka in these kind of IoT heavy applications that you see Kafka in. There's always a Rabbit or some other message broker that's actually doing the edge communication. Kafka cannot connect out to this many things. So in these architectures, this could be, Solace, and then there are different ways of connecting these into maybe your core brokers. These might be hardware up here. This could be hardware just due to the data amount, the volume, right? And this could be software brokers here in the cloud. These can be done with either VPN bridges, and we're developing DMR capabilities to kind of produce this type of tree topology. So in the product today, the event mesh, there are a number of different topologies that we support, such as cloud to cloud, multi-cloud, hybrid cloud. the horizontal scaling cluster. So, you know, if you have clients talking to a single broker, but you need them to be able to talk to a single broker needs to be able to talk to another broker. We have a full mesh topology where you can load balance. It's used for load balancing, horizontally load balancing connections in a specific region. But this tree topology is something that we're building into DMR right now. It can be done using VPN bridges internally here to talk about it. Obviously, the aggregate you know, message rates and stuff for these hardware appliances needs to be taken into consideration. Also, the addressing scheme. Like, we are working with certain customers, you know, IoT connected cars, where we're going to have millions of connected cars, and being able to reach out through topics, you know, and uniquely identify which broker and which car is in, you know, on which connection, and not just do unicast like this, but also be able to do broadcast, right? Like, if there's cars in a certain area, or you need to be able to tell all the cars, like, all of these vehicles have some number of subscriptions on it, right? So this might have his own personal subscription, but he also might have a kind of a global subscription. And so managing this state and being able to kind of not only ingest data going this way, but be able to kind of reach out and talk to these different endpoints uniquely, and in a broadcast sense, is not complicated, or is not trivial. I don't know what like if we have white papers on this, it might be. It's something that, you know, sales engineers will get into quite a bit when talking with customers. But there is, I have seen internally stuff that talks about this type of architecture, but we are going to be doing this with DMR. So yeah, without just, I would have to do a bunch of Googling. There's probably some blogs out there, but I would have to just spend some time going and looking to see kind of what exactly they are. Okay, let me pop back here. Design considered highly scalable. Yeah, yeah, it's been a while since I've done that kind of architecture question, so I would have to think and come back to it. But there are definitely challenges. It's not just the connection count, because you can kind of have that multi-tiered thing. It comes down to subscription management and volume of data, and sticky load balancing, right? That's another thing. So for this one connected cars use case that I can remember, let me just bring up the whiteboard again. In this one use case, there was an F5 load balancer kind of fronting all of these software brokers in the cloud. And it actually used some stickiness based on when the MQTT connection would try to connect, based on I think it was the VIN number of the car, or some unique identifier. And it would ensure that the car ended up back onto the broker that it came from. This is because, you know, for persistent messaging, obviously for direct messaging, you can just reconnect anywhere. You know, if there are messages published that you lost while you were offline, oh well. But for persistent messaging, where you need to be able to get back to your queues, you need to ensure that you get back to the broker that you're on. So there was some work with F5 to do a sticky load balancing to make sure that you got back to your broker. So yeah, I'm at about the limit of my knowledge on that particular topic. Pardon the topic. So that's about all I can say about that. But yeah, happy to, if you have more questions, head over to Solace community, ask them there. That's where we get a lot of questions, this type of stuff. We can continue our conversation later. Okay. Thanks. All right. Thanks. Oh yeah, thanks, Ari. Tree-tiered architectures. Yeah. Oh, the ACLs. That's a really good point. You don't want to have one car spoofing to be another car or something like that. So in the inside the Solace broker, we have this concept of ACLs, access control list, that determines which topics you're allowed to either publish on or subscribe to. These can be configured as a whitelist or a blacklist. So it allows you to kind of be restrictive about, certain clients are only allowed to publish or subscribe to certain topics. And obviously with millions of devices, we don't want to create millions of users and millions of ACLs. So we actually do variable substitution. So you can actually define an ACL with a variable name where you can actually have one level of your topic hierarchy be the client name or the something like that, client name or the username or something, so that when that publishes, it can only publish on something that matches itself. So, and that is authenticated using certificates. So yeah, there are cool ways of basically ensuring that whoever is connecting can only talk to themselves and can only subscribe to their own topics using dynamic ACLs. So some really cool features in Solace about that. One thing I got asked about yesterday, which was quite interesting, because this customer I had a workshop with was a real retail customer, but they were asking about MQTT. So the use of MQTT is definitely growing. When are we coming out with MQTT 5? And the answer I found out recently is very, very soon. So I think it's by the end of the year, this month, we're going to have an EA release of MQTT 5.0. I mean, Solace already has some MQTT 5 features, such as the shared subscription. I talked about that a little bit earlier today, you know, where you can have basically you can do round robin delivery or non-exclusive delivery using direct messaging, or QoS 0 if you're using MQTT talk. But yeah, MQTT 5 with native request reply support, with application property support, making it into a much more comprehensive and almost enterprisey kind of messaging format. So MQTT 5, very excited to have that in the broker. It should be, yeah, it's like first quarter. It'll actually be GA, but yeah, it's going to be as an EA this month. So very happy about that. If you've been waiting to hear about MQTT 5 and Solace, it is coming soon, very soon, along with our Python API, which is almost done from what I've been told. So if you want to use Python with Solace, head over to the community, solace.community, and ask there. There's a link right there. All right. Good questions, everybody. Thanks for that. Wow, my voice is getting a little sore. Oh yeah. Hey, tips and tricks. By the way, do people know, like, we have, you know, people come here and do Q&A, but we have this one section I find it actually quite useful. Tips and tricks, all things Solace, and not just necessarily Solace. Like, for example, get the biggest stuff. Yeah, in Solace APIs, there's message.dump, right? When you're printing your message to the screen, you can just dump it. I actually wrote some code here to basically produce the largest, yes, the most number of metadatas that you can populate in a message, just to see how long I could make a largest thing. There's so many different parts of a Solace message that most people don't actually know about. Anyway, that's something a little silly. What did I want to talk about? Oh yeah, Uli here posted a really good thing. If you're having troubleshooting, so one of our customers here was having trouble connecting using TLS. Everything would work fine using unsecure, but couldn't connect with using TLS. Here is a neat trick way of testing a TLS connection, being able to test it. Not just Solace, anything that's TLS, and it just uses OpenSSL. So cute or helpful tips and tricks in the tips and tricks section of the Solace community. I have a few other things I post here. Oh, this is actually super useful. If you're ever doing REST testing, you know, Solace has RDPs to be able to talk to REST endpoints. If you don't have one lying around, you know, some people use Postman Echo or webhooks.io. You know, there are online sites that allow you to do testing with REST. But this is a small little Java. This is Node. I don't really know JavaScript that well, but I made this Node web server, and will actually respond back to a web messaging. So if you're playing around with Solace's REST messaging or our REST micro gateway capabilities, having this running in a console is actually quite useful, and you can kind of see the headers and all that stuff. So yeah, grab this piece of code, stick it in your home directory or something, and fire it up if you ever need it. Anyway, well, it's kind of been quiet on the questions, so I think I'm going to slowly wrap it up. One thing I'd like to leave you, just to remind you again here, is the enterprise integration patterns. Talked about this a little bit at the beginning. This is a great website and a book The book was written quite a few years ago, but it really speaks to a lot of things in distributed application architecture. So if you're keen on distributed architectures, check this out. Check out this webpage. I really want to maybe make a kind of Solace comparison to how Solace fits into all of these different types of patterns. Yeah, check that out. Plug for Gregor there, and sign up for the Solace community. Come chat, ask us questions there. Give us a chat. Happy to do this. I'll be doing the next office hours probably sometime early in the year, maybe February. I will be doing a European one, European office hours, because this time zone is it's crack of dawn right now in Europe, so they're not going to be joining us. Yeah, hope. Yeah. Oh, okay. Hey, Tariq. Any links or white papers which talks about how Solace can help with on-prem cloud migrations, digital transformations? Yes, I'm sure there are. I don't know. Maybe Ari has. Ari, if you're out there, if you know some good links, I would have to go digging around. But there must be. I mean, like we have blogs and all sorts of things that talk about this, because this is a huge part of our yeah, it's a part of our business is on-prem to cloud migrations. We do hybrid cloud. Having a technology that can run in pretty much any cloud or any on-prem scenario. You know, on-prem you got Kubernetes. In cloud we have, you know, the software broker can run in GCP, AWS, Azure, Ali Cloud, Huawei Cloud, and you know, building applications that talk to all of these different clouds really makes it able to move your applications where they need to be. You know, like if you write it on-prem and it talks to Solace, you can move it to any cloud later on and it talks to Solace. And with the event mesh, it really allows that data to kind of just flow where it needs to go. Anyway, somewhere on here there must be some white papers. I'll do some poking after I end the broadcast, and I'll maybe post them up. Yeah, there has to be some information here. I don't have that link ready. Yeah, me neither. Come to the community. Ask us there. Solace.community. Ask us any questions. We will go and find these white papers. We will go and find some of the papers and let you know. Solace.community is the spot to check that out. So thanks, Ari. Yeah, I'd have to go figure it out. Any chance I need to take a dump of messages from a queue and put it back when required? You mean built into the broker? There, you could do something like, well, take a dump. What does that mean? Does that mean actually consume all the messages and then consume them again? Solace does have replay, you know, for guaranteed messaging. So if you needed to, I don't know, if you wanted to like delete all the messages that are in a queue and then replay them later on, you could do that. That's built in. If you wanted to dump, as in hook up a consumer application and kind of read through them all, and then replay it again later, you could do that as well. So yeah, check out the replay feature. It's built in. It's free. If you have the software broker running locally, you know, the Docker container or the machine image, just go into your VPN setting. There's a thing, the replay. Turn it on and play with it. You know, publish to a queue and then try to do a replay on it later on. It's pretty straightforward. I think. Yeah, it depends what you mean by a dump. If you mean just delete them all and like put them back later, yeah, the replay feature can do that. So check that out. Good question there. That's interesting. All right. Here's a telco success story. Thanks, Ari. There you go, Tariq. There is a link from Ari there about customer success story. That's pretty recent, I think, isn't it? That's a pretty new one. So chat, if you want to read about customer moving to the cloud, hybrid cloud with Solace, there is the link there. Which way is that point? Check this out. All right. Okay. So that is at the top of the hour. I'm going to. I think I'm going to kind of wrap it up. So yeah, thanks for joining, everybody that was tuned in. Happy to be doing these. There we go. Happy to be doing these office hours. If I don't talk to you, if I don't see you on the community, have a happy new year, happy holidays wherever you are in the world, and yeah, see you in 2021. And talk to you later. Okay, bye bye.